puts that behind the up return code.
But it puts hex encodes.
Hex encodes our string, in this case, your secret is safe with the blockchain.
So we can see it on the.
So if we were to go to, for example, this Explorer that looks at op returns, and we're just looking at the test net.
So you can see it show up as the newest transaction there.
Something silly, fun. And the idea, of course, is that this allows us to springboard and more easily put information on the blockchain very quickly, in which we can now use it as a notary service for something more interesting or more practical, as putting up information about discoveries. And then later having maybe on top of that, layered on top, a consensus model of where, well, did this actually occur, using, in our case, since astronomy is a limited field, perhaps maybe trusted astronomers in particular subcategories, comets, asteroids, etc. But let's see, let's take a look at what we learned. I mean, I sometimes run down a certain path, and I ran down the Bitcore path hard, and it was till the very end that I realized I got to start using other things. I couldn't get the Peer Manager to work, and I didn't want to try Insight just yet because I thought, I don't want to do one more thing. And then I just, learned about, didn't even know what Express was. I mean, I thought you could just copy paste this and just run on it. So she's okay. She's more the tech.
So we both never used Node.js, and then we found that we install Express and use the Express generator, and we install a lot of the required packages, and then for parsing information from front end to the back end.
Well, here you want to talk about this. This is the actual app.js.
So this first part, this is the code that took the information from the front end and passed to the back end. And then over here we use the Bitcoin.js library and the chain node packages. And here we're building the transaction. We took the newest transaction ID from our address. So we generated a pair of public and private key ourselves. And because of the testnet properties, we can keep chaining these transactions one after another. So we are using the same pair of public-private key for all these transactions that we're building. So those two things never change. The only thing that changes the transaction ID. Now we have to pull this manually from our transaction every time it happens, but ideally we would want to pull this using the block Cipher API. So it shows you even the newest unconfirmed transactions for a particular public address. So we just found that last night, and we're going to implement that in the future.
Yeah, you want to talk about block Cipher?
Yeah, so for block Cipher API, so this is for the public key that we're using. And then you can see this is the newest transaction that is showing. So there is one unconfirmed transaction. That's the one that we just sent. And it's probably at the very end.
Yeah.
And we can pull that up for the next transaction review.
Yeah, so again, just really learned a lot. I mean, and I can't stress that enough. I mean, personally, I myself, I didn't know that Java and JavaScript were not the same thing until this. So, sadly,
that's your confession.
That's my confession. I didn't want that though forever on the blockchain. So, but yeah, Yvonne really, figured out.
Jeff's the one who figured out how to do the op return.
Well, I was just, I was just playing around, and then, what got me on this, when you look further down, I was just, where was it? Where it goes, hey Jeff, man, who are you? And I thought, oh, that's so cool. We should, figure this out. Well, that's not here anyways. Anyways.
I'm gonna pull up the confessions, and then she'll do the shot with the confessions.
Oh yeah. Coin fashion.
Questions from the judges or anybody?
Yes.
So the idea is only the sender at some point can reverse or get back the confession, right?
So the idea.
The question is,
Oh, I'm sorry, yeah. The question is, so could the sender receive back their confession later and look at it? So yeah, ultimately the idea would be to pull that back out and they could see it.
The thing is because after each transaction we send, we actually can log that new transaction ID. So what we could do is we put that into a database and then link it to a block explorer and then say chain.so and it will even display your op return message.
Oh, it
there.
will. It's not encrypted. Like you don't need the private key to unencrypt the confession.
So the question is, do you have to have is that an unencrypted message? Basically, yes, it
Oh,
is.
okay.
So it's basically straight out there, just hex encoded and out. Actually, well, hex to string, yeah. So the idea, a lot of ideas play on this, and they put in front of it an identifier to quickly see proof of existence, CoinSpark, many other ones. And personally, I was thinking about that. That's just losing valuable character space. So why not just have 2 bits of information, transaction ID, which you have, and then the actual message. So you're not wasting a single character. You can use every single one of those bytes.
thanks Jeff and Yvonne. While Yvonne was busy mapping all the bodies that